Welcome. This video is going to take a closer look at Bohr's ideas about ground state and excited states and this whole idea of energy levels and where electrons tend to hang out. So principal quantum numbers is the fancy name for energy levels, or what you might know as electron shells, but these concentric circles that get bigger as you move out from the nucleus. And this is the part of Bohr's model that scientists believe was correct. Principal quantum numbers are also known as n, I guess for number. And the bigger the number, it indicates the relative size and energy level of a shell. So 1 is the smallest energy level, and it has the least amount of energy. So think of this as being your swing with the shortest chain. So the easiest to get going, but also the closest to the center. So then as you move out and you get to 2, 3, 4, 5, 6, and 7, the shells get bigger, and as it says, the electrons spend more time further from the nucleus, which increases the energy. Then there's this whole idea of energy sublevels. So as these energy levels get bigger, it makes sense that more electrons can hang out in these bigger energy levels. But electrons all have negative charge on them, so electrons aren't going to get too close together. So scientists now believe that these principal energy levels contain sublevels, or what are known as atomic orbitals. And I tend to use the word orbital rather than sublevel, but they mean the same thing. Sub means, within or below. So energy levels, I think of like floors in a dorm, an apartment building, and the sublevels or orbitals are the number of rooms on each floor. Or the book talks about thinking of as energy sublevels like increasing number of sections when you have bigger rows in a stadium as you go out from the football field or whatever the stadium is for. But try and get a visual of this idea of the energy levels and then these sublevels or compartments, orbitals within the levels. So sublevels or orbitals are labeled S, P, D, or F according to their shape, and the letters stand for sharp, principal, diffuse, and fundamental. I don't know how that describes shapes. I tend to think of them as spherical, peanut, double peanut, and funky, and I'll show you pictures a little later here to show you what I mean by that. But the bigger the energy level, the more sublevels. So again, thinking with the dorm analogy, if you have a bigger floor, there's more dorm rooms. And each orbital or sublevel, regardless of what kind it is or what shape it is, can only hold a maximum of 2 electrons. So each dorm room only holds 2 people. And the reason for this is because electrons, as they're constantly moving, they also spin, just like the Earth rotates around the sun, but it also spins on its axis. Same thing with electrons, and they either have a clockwise spin or a counterclockwise spin. And you only have an electron with each type of spin hanging out near each other. So you can have one going one direction, one going the opposite direction. But when you get that third one there, now you've got 2 of them going the same direction. And that creates a lot of energy, repulsive energy, so they don't hang around each other. So just to recap here, you're going to have an energy level like a floor. You're going to have these sublevels or orbitals, and each sublevel or orbital will hold just 2 electrons. So atomic orbitals or energy sublevels are the 3-dimensional region around the nucleus where an electron can probably be found. And the denser the dots, the more likely you are to find an electron there. So, and that's referring to this image to the right where you have some kind of computer image showing where the electrons are most of the time. These dots just represent where the electrons hang out a lot. And they actually draw the boundary around the area where the electron is found 90% of the time. So just like, state borders, there's not actually, a big line there or a big fence or anything. Same thing with these boundaries for these energy levels or these orbitals. And so the way it works out is energy level 1's the smallest energy level because it's the closest, so shortest chain on your swing. So there's only one orbital in energy level 1, and that's an s orbital. In energy level 2, there's actually 2 kinds of orbitals. There's the 1s orbital, or actually this is a slightly bigger s orbital, and then there's also 3 p orbitals. And when you get out to energy level 3, now 3 kinds of orbitals show up. There's an s, there's 3p, and now there's 5 d orbitals. And when you get to the 4th through the 7th level, you have all 4 kinds of orbitals available: the s, the p, the d, and the f. And the number of each is 1, 3, 5, and 7. So definitely some mathematics going on. And this isn't anything you have to memorize. This is something we will work with and will become common to you fairly quickly. But it is the order that they fill up. They fill up the s orbital first, then the p, then the d, then the f on any floor. So you could think of, the s being the cheaper apartments, so people are going to fill those up first, p being a little more, then d, then f. And the way I remember it is just this acronym, some poor dumb fool, SPDF. And then just to finish up, here's what scientists think they look like. This isn't particularly important to us either, although I think having a visual helps. But you notice that the s orbital, I think of that as being spherical. I think most people would. The p, some people describe that as a dumbbell shape, but I like to describe it as a peanut shape since it starts with p. And there's 3 of them because they can lie in 3 different planes. You can be, back and forth, up and down, front and back. And then the double peanut lies in the planes in between the x, y, and z planes. So the double peanut end up with a total of 5 different orbitals. And then the f orbitals, those just get really strange. But the reason why is each orbital is trying to find space where other pairs of electrons aren't already hanging out. So that is a quick look at atomic orbitals or sublevels.